Basic question. Question A. If p hat is the proportion of the sample who did attend church or synagogue, what is the mean of the sampling distribution of p hat? What is its standard deviation? So the mean is equal to p, and p is equal to 0.4, which is given to you. And then to find the standard deviation, you take 0.4 times 0.6 over 1785 and take the square root of that, which is 0.0116. Part B. Explain why you can use the formula for the standard deviation of p hat in this setting. Rule of thumb 1. So rule of thumb 1 is standard deviation of p hat only when the population size is at least 10 times as large as the sample size. And the population size is US adults, and the sample size is 1,785, and there's definitely at least 10 times more US adults than 1,785. Part C. Check that you can use the normal approximation for the distribution of p hat. Rule of thumb 2. So rule of thumb 2 is normal approximation for the distribution of p hat can be used when NP is greater than or equal to 10 and NQ is greater than or equal to 10. So as you can see, 1,785 times 0.4 is equal to 714, which is greater than or equal to 10, and then 1,785 times 0.6 is equal to 1,071, which is greater than or equal to 10. Find the probability that p hat takes a value between 0.37 and 0.43. Will an SRS of size 1,785 usually give a result p hat within plus or minus 3% points of the true population portion? Explain. So what you do is you take the z-score, both of those, and that'll be negative 2.586 and positive 2.586, and that is equal to 0.9902, and so the probability is 0.0049 and 99 or 0.9951, and so 99% of all samples should be within plus or minus 3% of the population proportion. Advanced question. Part A. Construct and interpret a 95% confidence interval for the mean difference in the estimates from these two methods in the population of tires. So what you do is you take the CI formula, which is equal to the mean plus T star times S over square root of N. And so the mean is 4.556 and the T star is 2.131. And so what you do is you plug those things in, and you can be 95% confident that the interval from 2.837 and 6.275 captures the true mean difference of the population of tires. Part B. Does your interval in Part A give convincing evidence of a difference in the two methods of estimating tire wear? Justify your answer. Yes, the difference between 2.837 and 6.725 is not zero, and there is a positive range. Therefore, that justifies that there is convincing evidence. AP question. Part A. If the manufacturer sets the mean distance traveled to be equal to 208 yards, what is the probability that a ball that is randomly selected for testing will travel too far? So you take the z-score, and all of those are given to you, and that is equal to 1.14, which you go into the table and find out that is equal to 0.8729. So then you take 1 minus 0.8729, which is equal to 0.1271, and so there's 12.71% probability that a ball will travel too far. Part B. Assume that the mean distance traveled is 208 yards and that 5 balls are independently tested. What is the probability that at least one of the 5 balls will exceed the maximum distance of 291.2 yards? So what you do is essentially, after you do all that math up there, you get 1 minus 0.50678, which is equal to 0.4932. So the probability of at least one of the 5 balls exceeding the maximum of 291.2 yards is 49.32%. Part C. If the manufacturer wants to be 99% certain that a randomly selected ball will not exceed the maximum distance of 291.2 yards, what is the largest mean that can be used in the manufacturing process? So what you do is you go to the table to find the 99%, and that is equal to 2.33, so you do 2.33 is equal to 291 minus x over 2.8, and then you solve for x, and x is equal to 284.68. And that's the largest mean that you could have without exceeding.